So here's quiz 4.4b. This is an example. And the first one is find the point on the curve y equals 4 minus 2 times the square root of x that is closest to the point 5, 4. So I drew kind of a sketch. You could look at this on your calculator, but these problems you won't be able to use the calculator, so you have to do a little bit of work on these. But anyway, so I kind of sketched this. And remember, the square root of x here, if we look at this, we're just kind of flipping this a little bit over here. So this is 4. I'm shifting this up, and this is negative the square root of x. Remember, the square root of x is like John Travolta, goes like that. But we're flipping it, so it's going to go like that. We're also multiplying it by 2. So each of these values is going to be going down by 2, so we're kind of stretching it down, so to speak. But we're shifting it up 4. So we start over here, and it's easy to see when x is 0, y is 4. So you actually could put a couple points in here and get it just as easy. And when x is 1, 4 times 2 minus 1 was, because the square root of 1 is 1. So 4 times 2 is 2, so I have that point there. And when x is 4, the square root of 4 is 2. 2 times 2 is 4, so 4 minus 4 is 0. So you can actually put some points in there and get it pretty fast. And what we're trying to do is we're trying to find the point on this curve. So it says find the point on the curve. Go back over here. Find the point on this curve, 4 minus 2 times the square root of x, that is closest to the point 5, 4. So this is the point xy, and we want to find what the values of x and y are that will make this point closest to this point here, or this distance, to be the smallest. All right, here this distance from here, this point, is bigger than this. So we want to make this distance the smallest. Okay, so that would make that whatever makes this distance between this point and this point the smallest would make this point on the curve closer to this point. So that's what we're going to try to do. So we're going to have to use our distance formula. And I hope you remember the distance formula. We've got 2 points, x and y. Distance equals, the square root is kind of like the Pythagorean theorem. x2 minus x1 squared plus y2 minus y1 squared, and that would give you the distance from 2 points x2 and x1, y1, and x2, y2. All right? So we're going to kind of put this in. So we want our distance here. Let's try something different here. And we're trying to find the distance between the point 5, 4 and xy. So that point I put on the curve in red, that was xy. And remember, this is on the curve. Y equals 4 minus 2 times the square root of x. Okay? And then my other point is, I had that 5, 4. So if I think of this is going to be my x2, y2. And this will be my x1, y1. So now we just put this in the formula. And this is my x and y. And then there's my 5 and 4. And fill that in. And there you have it. Now, this is what we're going to try to take the derivative of, but the problem is that it is not in one unknown, it's in 2 unknowns. So we're going to have to use this reality that y is actually equal to 4 minus 2 times the square root of x. And this is kind of like our constraint. Okay? So this is going to allow us to reduce this distance, which is what we want to minimize. This is the distance. Okay? We want to minimize that, so we're going to use this reality here. So we'll rewrite this. And that's going to be x minus 5 squared plus, and what was y? Y was the same thing as 4 minus 2 square roots of x. So I'll put that in. See, that's what y is, and then minus the 4. So you can see that. And that's going to be all squared. Okay. Now this works nicely because 4 minus 4 is 0. Okay. So we end up with our distance equal to x minus 5 squared, and then plus, and this is going to be negative 2 times the square root of x squared. Okay. And then when I just square both these out, I get distance equals, and this is going to be the square root of x squared minus 10x plus 25, and then plus over here, that's 10x, pardon me, and then negative times a negative is positive, so it'll be 4, and the square root of x squared is just x. And I can combine these, and I've got distance equals the square root of x squared, and negative 10x plus 4x is negative 6x plus 25. Now this is what we want to minimize. Now, if you think about the square root function, it's a one-to-one function. All right? So just look at this over here. And it's also monotonic. It's always increasing. So this is actually the square root. This is y equals the square root of x. So we need to notice that as x gets smaller, the square root of x gets smaller. So this is what's inside the radical in this case. And this is the actually square root of this. So since it's decreasing, since it's monotonic, if I can make x a minimum, that's also going to make the square root of x a minimum, because it gets smaller and smaller. Does everybody see that? Okay? Well, that's all of you. Does everybody? So do you see that? In other words, as x gets smaller, all right, the square root of x gets smaller. So if I make x a minimum, I'm making the square root of x a minimum. So I'm going to call this inside here g of x. And that's just the radicand. That's what's inside. So we don't have to take the derivative of the square root. We can just take the derivative of this function, and that's going to give us our minimum. It's going to work the same. Because if this is a minimum, the whole thing will be a minimum. Again, because it's monotonic. It's always increasing, so as I go to the left, it's always decreasing. As I go from here to here, it's getting smaller and smaller. Okay? So let's take the derivative here to see what value is going to make this the smallest, which will make this distance the smallest. You see, go all the way back up here. This will make the distance the smallest. So g of x, g prime of x equals what? So this is relatively easy. 2x minus 6. And we want to set that, is that going to be undefined? G prime equals 0, or g prime undefined. Well, that's not going to be undefined because it's a polynomial, so we're just going to set it equal to 0. And that's the x-coordinate. That's my red x I'm looking for up here. That's the x-coordinate that's on this curve that we talked about. So x is 3. Now we have to find out the y-coordinate because we want the point, and the point's going to have an x and a y. So what's the y-coordinate? Well, we have our equation, and it was y equals 4 minus 2 times the square root of x. So y will equal 4 minus 2 times the square root, and x was 3. And that's pretty much all you can do, because we're not going to use a calculator and have you estimate that. So our point will be, so you'll leave it in this form. Three comma 4 minus 2 times the square root of 3. Okay. Now you can approximate that if you want, because remember we said we use the square root of 3 as 1.7. So 4 minus 2 times 1.7, that's 4 minus, that's going to be 3.4. So that's going to be approximately 0.6. So our point would be approximately, well, 3 and then approximately 0.6. Now if you look at the little sketch I made, this actually was a pretty good sketch. Because if we go over here, I kind of looked at and said, well, this looks like this is the minimum, and it looks like it's at 3. Here's 1, and this is a little bit more than, or about a half, so it looks like it's about 3 and 0.6. So 3.6. So it looks like XY was pretty close. If you kind of approximate that, but you can just leave it in radical form, and that will be fine. So take a look at this one. This is a good application. And then again, we're doing the same idea. We have a primary equation. This was our primary equation. That's what we want to take the derivative of, but we want to reduce it. So this is our constraint. So don't forget that this is the constraint over here. Or the secondary equation. Primary equation, secondary equation, and we use the secondary equation to reduce the primary equation from 2 unknowns to 1 unknown, and then we can go to town. Okay? Hope that helps.